All right, so project ideas. Now this one's got a much longer write-up than it really is difficult. I mean, it looks difficult just because it's like 20 pages long. Well, it's not really, right? It's got several examples and stuff like that. The idea behind it is just it's like a, you know, fantasy role-playing game where you have a character and he's got a strength and he's got a, you know, an attack and he's got a shield and you got two characters that are going to be whacking at each other. And no, it's not animated, right? You're just going to write a program that simulates that, right? You're going to print out their strength and their defense and their attacks. And the method by which the attacks are resolved is really pretty simple. So I don't know why it seemed to take so long to explain it. Maybe I need to rewrite it. I'm thinking about uploading a video that just shows the game in progress with pauses in it while I talk about it, and then you would absolutely understand the rules. Just like if you sat down, you know, to play D&D with somebody, it's awfully helpful to have somebody who's played it in the past. All right, so the first one's called Pie Fighter. The program will implement a combat system for an imaginary game called Pie Fighter. Some people decided it was TIE Fighter, you know, make it a space game rather than two characters. Read the document carefully, including a sample of the complete battle. Alrighty. So what you gonna do? Why don't we just find the example? Okay. So every fighter has 4 attributes, stats. They have a name. I am Conan. They have a combat rating. I have a combat rating of 30. They have armor. I don't know why I put an S there. Kind of needed to edit that. Oh, I've got armors. Doesn't sound right. Got armor, some kind of armor rating, and then how many dice they roll in combat, right? Like somebody might roll 2 dice, or they might roll 10, or something like that. And that's what this explains. So, for example, Conan's got a combat rating of 10. Armor of 2, and he gets to roll 5 attack dice. So the program should ask these stats for 2 fighters. I guess you can make them random, but it's more fun if you get to type them in. And so every combat round, what do? You determine the attacks, right? Conan versus Trogdor. You know, one's going to roll this many dice, one's going to roll this many dice. And then you compare the attacks to determine the loser. Conan rolls more, right? He rolled a 20, Trogdor rolled a 10. So there's a 10-point difference. So that's the damage. There's going to be 10 points. However, that's reduced by the armor. Trogdor has an armor of 5, and he was supposed to take 10 damage, then he only takes 5. And then that's reduced from their combat rating, and it repeats over and over. Now there is a special rule for how the combat roll is determined, because they get to roll all their dice, but also they get to add half their combat rating. So if they have a combat rating of 10, then they get to add 5 bonus points to their roll, right? And so that's the total attack, is their dice plus the half of their combat rating. So you can see that once you start losing, I ought to change that to health rather than combat rating. I ought to change that to health. Maybe I'll do that because people have the idea of health. Once you start losing, that character starts losing really fast, right? Because their dice rolls are reduced. All right, and then there's a big long example. You know, first a big long example of the rules, and then a big long example of how the thing would actually work. Conan rolls a 3-3-6-2-3 plus his combat bonus of 5. He gets a 22. Trogdor rolls all of those plus a combat bonus of 5 for 25. So Conan's total is that. Trogdor's attack is 20 is that. You don't have to make your output look exactly like that, but I better be able to tell, you know, the rolls and stuff like that. So the damage would have been 2, 24 and 22, but Conan's armor absorbs 1. So he's hit for 2 points. Well, that doesn't make sense. I need to rewrite the program. I failed my own assignment. Right. Should be 1 point. And then Conan's CR should have dropped by 1. And it repeats over and over. Now, the problem is that if their armor is too high, they'll never take damage. Right. They'll sit there rolling forever. Never take any damage. So you ought to find a way of fixing that problem. You don't want your program to go into an infinite loop just because these 2 guys are too well armored. What might you do? I don't know. You might reduce their armor, you know, after a certain number of turns, right? They're starting to get tired, right? You know, so their armor is weakening or something like that. Yeah, you could figure it out. Or I guess you could just run for 20 turns and then declare them a tie. That's kind of the, you know, the fallback idea. All right. I hope that one sounds interesting.
Do you have all these uploaded?
Yes, yes, they will be uploaded very quickly.
Okay, because you only have one in the project.
Right, there's one in the projects folder. The rest of these are going to go there as well. All right, Hangman. We know how to play Hangman, but we're going to look at the document anyways. Let's play Hangman. I'm thinking of a word. It's 7 letters long. Guess a letter. Be careful. You can only make 8 mistakes. I guessed an A. Woohoo! All right. Kind of like playing, not Jeopardy. What's the other game on the TV where you're actually kind of playing? I'm going to pick a letter. Yeah, Wheel of Fortune. Yeah. All right, guess a letter. B. Incorrect. You can only make 7 more mistakes. C. Nope, there's no C's in it. You can only make 6. Guess a letter. G. Woohoo, there's a G in it. Guess a letter. N. There's an N in it. Okay, I think I know what the word is. Right? Maybe we should let them actually take a guess. Right? Do you think you know what the word is? Yes? No? Yeah? What's the word? They type in Hangman. You win. Something like that, right? Or otherwise, once you get it, you could just keep guessing the letters, right? At this point, we know it's Hangman, and so all we would have to do is guess an H and an M, and it would be over. Like I said, I would be watching this one really, really carefully. It's kind of the simplest of the projects in my mind. Maybe not yours. But it's too tempting to go out and grab it. All right, another one, Mastermind. If you ever played Mastermind as a kid, you already have the idea of this. The way it works is kind of the judge, the jury, the dungeon master, the whatever, sets up a little code based on the colors of the pegs. And then the player comes over here and he starts trying to guess. Right, so his first guess, not that I can really see, got a white and a blue and a green and a black. Now he didn't get any of them in the right place. So he didn't get any black pegs in his status. However, he got some of the colors right. He got a black and he got a green. So he got a notice that you got 2 letters right, but they're in the wrong place. That's what the white pegs mean. So rearrange these. Oh, bummer, I only got 1 right. By the time we get to here, he's starting to get them not only right, but in the right position. He got the black one in the right position. He got the red one in the right position. But there's no white one and there's no blue one. He got even closer with that one, right, because he got the yellow one in the right place. And then he figured out, okay. So that's how Mastermind works. This one's a little bit different than using colors, although I guess, you know, if you want to go all out, you could, you know, actually draw this as a graphical user interface, but we're not going to go too much in that. That doesn't mean you can't research how to do graphical user interfaces. We will broach them. Anyways, so what are you going to do? The code is going to be 4 digits long based on numbers 1 through 5. So the computer secretly chooses 5432 as their code. We guess 1, 2, 3, 4. Well, that means that the 2 and the 3 and the 4 are in the list. Are any of them in the right place? The 3 is in the right place. So there is 1 correct, but 2 of them in the wrong place, right? And then so the cheaty way of trying to distinguish whether, you know, that color exists or not is to just guess the whole thing. Yo, are there any 1s in it? No, there weren't. So we tell them that. No correct, no misplaced. All right. We could guess, are there any 2s? And we would guess that there was 1 correct. Right. But dude's trying to mess it up, right? You know, trying to mix it up, trying to get to a faster answer. And so on. I have some examples, how I want it to work. The question becomes, what if you have duplicate digits, right? I guess we can make it simpler and insist that there's no duplicate digits in the original code. But here in this case, they guessed a 2 and they guessed a 1 and they guessed a 1 and they guessed a 2. We don't want to count that 2 as being correct because there's only 1, 2 in the project. So the last one is correct, but the first one, there is no second 2 in it. So we wouldn't want to tell them that it was misplaced. We just want to tell them that they didn't get anything right. Hope that makes sense. All right, so that's Mastermind. Some people do that one because they get the idea, especially if they played it as a kid. Here's another one. Word and letter count. Your program will read a text file and print a table of how many times each word appears in the file. Also print a table of how many times each letter appears in the file. Now this is almost absurdly easy compared since we've already done something very similar to this where I had you type in a sentence and it was supposed to print the words and the letters, but it didn't calculate which ones were the most common. That's not too difficult to do if you use something called the dictionaries, which we will learn. A dictionary is like a list, but it's more specialized. A dictionary, no, I'm not going to even get distracted. You get the idea. It'd be really cool if you drew a bar graph of the letter counts. So we read a page, and here are all the words in it, and they're not even sorted, right? It looks like we have 5 I's. Looks like they're sorted by the, the word and not the count. And that's as a result of using the dictionary in the way that I did. I write all these myself to kind of judge the relative difficulty of it, just to make sure that they're doable by students, right? I don't want to give you something that would take, a computer science, major a week to do. And then a sample output for every letter. There's more A's than there are B's. There's a whole bunch of E's. There certainly are, a fair amount of R's. For some reason, there were almost as many N's as A's, and so on. And if you're going to print a bar chart, you might just print that many asterisks, right? 31 A's, 2 B's, 5 C's, 12 D's, and so on like that. The problem with that is, what if your asterisks run off the edge of the screen, right? What if we read on a huge file and it's got, 2,000 A's? You might try to find a way of adjusting the number of asterisks. Oh, that would be cool. You get bonus points if you display a bar graph. And it's also cool if you save the output as a file, right? Which is also really pretty easy. Saving to a file is almost as easy as printing to the screen. All right, and then the last idea. This is the one that's already uploaded to our class. The others will be pretty soon. They'll all be listed in a folder called Project Ideas. And of course, there'll be a folder in our main assignment that'll list the project ideas as well. All right, this is one that, since this one devoted almost an entire chapter to Caesar Cipher, I thought it would be an interesting one. How do you decrypt a Caesar Cipher? Well, there's really 2 ways of decrypting it. One is just to try every possible key value, right? From -100 to +100, and if suddenly the text pops out, then you got it right. And I'll upload that as another project idea. That one is a fairly simple project, in my opinion, right? Because you write the Caesar Cipher program, but all it has to do is loop with key values, right, until you find something that looks like a good result. And you go, hey, I decrypted it. It's awesome. I'll upload that one. I usually give that one to my Java class. I don't know why it's not in the Python class. Okay, so what's this one going to do? Another way of decrypting, because we talked about more complex ciphers as well, right? One that not only shifted 1, 2, 3, 4, shifted everything by 1, but another one that shifted, based on almost the random numbers, right? Or shifted based on an increasing sequence. The first character was shifted 1, the second character was shifted 2, the third character was shifted 3. Or that we shifted it based on a series of shift values based on another word, right? So we've talked about a lot of variants. And this particular manner would work to a fair degree on any of them. And it's fairly close. I won't go on to that. So one thing you can do is, one thing that cryptologists do is they use lists of the most frequent letters in the English language. And then they also use lists of the most common 2-letter words and the most common 3-letter words. Sounds like a Scrabble dictionary or something like that, right? And they look for patterns in it. Well, this one I didn't design to use the 2-letter words and the 3-letter words, but I will give you a list of the most common characters that exist in the message that I want you to decrypt. That makes it real easy for you, actually. Not that this is an easy solution project. For me, it was the most difficult of the ones that I wrote, the programs that I wrote. Doesn't mean that I don't want you to do it, You could work with me if you get stuck on it and stuff like that. But anyways, so I've decided, according to the message that I encrypted, that the most common character is a space. Kind of makes sense, right? There's a space before every word. After that, E's are the second most common, A's are the third most common, S's are the fourth, H's are the fifth. So based on that information, and based on the encrypted text that I will give you, you ought to be able to go through, figure out the most common characters in the secret message. And in this case, the most common character is an exclamation mark. Well, that's probably a space. This next most common character is an F. Well, that's probably an E, and so on. Go ahead and decrypt this using that as your key, going, okay, I'm going to replace every exclamation mark with a space. I'm going to replace every F with an E. I'm going to replace every B with an A. You can see that I just did a shift by one, right? Every T with an S, and so on. And after you replace all these, so this is the part you got to do, is you got to figure out, you know, the most common characters in that message, and then you've got to apply a replacement so that every exclamation mark, or whatever it is, right? You know, I'm going to code it differently than this one because, you know, this one gives the answers away. You'll come up with that. You'll do a replacement, that with that, that with that, that with that. And if you get a result that looks like it was written in English, I'm not going to give you Russian or something like that, then you're good to go, right? And so based on these like 15 characters or whatever, replacing those, then our decrypted message looks like this. And at random, I just chose a Bible verse because I found, you know, a huge, you know, list of Bible verses I could copy and paste. But, you know, if you don't like Bible verses, you know, ask me for a Harry Potter chapter or something like that, right? And so anyways, you're going to print out your result, and if it looks like English, you're going to go, boom, I got it. That's possible that I could give you several different frequency lists, right? I could give you one, and then the other one, and then the other one, and maybe you could try one, and if it didn't work, you could try a second one, and it didn't work, and then if you tried a third one, it didn't work. So I will give you the text file and the frequency of the characters because they differ for every file, right? You know, if this file is a lot about zoology and zebras, there are going to be a lot more Z's in it than this reflects, right? So if you want to do this one, let me know. I'll give you the file, you know, and I'll give you the common characters that I want you to use. Now that I present it like this, now that I've thought it through and presented it like this, I think I could write it way more quickly than I did the first time. So maybe it's an easier project than I just built it up. You could judge for yourself whether it looks like a hard one or not. Now that I'm discussing it, it doesn't look nearly as hard. I'm not sure why I struggled this much with it. But I was also encrypting it. Anyways, yeah, okay. So those are the project ideas. The other one that I mentioned is where you do a Caesar cipher, but you keep rotating the key, you know, from -100 to +100 or -65 to +65 or whatever it'll give us, you know. And then I will have given you an encrypted message, and you'll just run all those, you know, numbers against it and get the result. And the last thing that I would like to offer that I haven't done, I'll come up with it by Tuesday, would be one where you just implement an enciphering and a deciphering program based on that idea of a sequential shift value, right? The first letter we shift by 1, the second letter we shift by 2, the third one by 3, or something like that. Yeah. That one probably wouldn't be too difficult either. I'll write that one and upload it as well as these. So there's 2 extra ones to upload. Let me make a note of that. Hope I started the recording. Yep. If you want to come up with your own, that's totally okay. Just make sure that it's not so difficult you can't accomplish it. Right. When I was pursuing my degrees and we had the projects to choose, sometimes I chose ones that were extremely difficult to finish by the time. I'm not bragging, and they may have been easy projects, and I just didn't do it right. You know, I got them finished, but they were very challenging. Okay, so things I want to add to our project list. You know, sequential key. Shift key for Caesar cipher. What are you doing? All right. Then we had another one. I give you an encrypted message and encrypted. and you apply a series of shift values until you decrypt the message. And it seems like I mentioned a third one I wanted to give you, and I've already spaced out on it. Anybody remember the ones I was discussing as optional? I mean, not optional, but ones I hadn't put down on paper yet. This one I have written up. This one I just came up with at the beginning. I mean, at the very end. And there was one more. What was it? Oh well, that's good enough. If you hate all these and you can't come up with your own idea, then ask me and I'll try to come up with another one for you. Make sense? All right. That Pi Fighter instruction got longer and longer as lots of people chose it and then got stumbling blocked. That's why that thing wound up being 5 pages long to try to explain the rules very carefully. So we talked a lot about getting the ordinal value of a character, right? X is equal to the ordinal value of X, or A, just because I happen to have that one memorized. The ordinal value of that is a 65. Or X is equal to the ordinal value of a space. That's a 32. Happen to have those two memorized. Don't have any of the others memorized, except the lowercase a is 32 beyond that, just because of the way they designed the table. Then we talked, another word for ordinal value is ASCII value. Converting back from ordinal values to a character is done like this. CH is equal to CHR. I think I'll just make a C. And then you give it an ordinal value. Like if you did 65, it's going to take it back to being an A. Or if you get the character value of a 32, then you would get, right, a space. Yep. One more to throw at you just because it looks weird. An ordinal value of a new line character, a \n, is a 10. I do believe. And so if we took the character value of a 10, we get a new line character. We talked about is upper and is lower and stuff like that. So if you do if C dot is upper, if it's uppercase, then it's true, right? We also talked about is lower. No, I'm not sure we talked about is lower and is. Yeah, I think we did. C dot is lower, right? I don't know why I put this inside parentheses. I was thinking of languages that require that. And is digit. What's some of the other ones we used? We used several more. Is space to see if it's white space. Is it a space, tab, or new line? So-called white space.
Is alnum?
Yep, is alnum. It's an alphabet character or number. And is alpha, it's an alphabet character. In other words, a letter. And is digit. It's a digit. Now when I say it's a digit, these really should be thought of, it's composed entirely of. So I should rewrite these to say it's entirely composed of alphabet characters or numbers. And ditto. So, and it is entirely composed of spaces, tabs, or new line characters. Okay, I think that's it. Oh, I already had this digit. And similarly, if it is entirely uppercase, right? If it is entirely lowercase. Oh, you just be quiet. Turn you off. I apologize for that merry melody. Here we go. Okay. What could you use this for? Well, say you ask for some input. And you want to make sure it's digits before you call the integer function. Well, we've been calling float already, which handles, the dot in it, and then we could turn it into an int after that. But we might want to try to handle input and check to make sure it's valid input, in which case you could call isDigit, right? And if it's not isDigit, if it's not all digits, then you better yell at them. Now, checking to see if something is a number could be a little bit more complicated than that, because what if they threw a dot in, right? What if they threw a period in? And isDigit does not count a period as a digit. Or what if they're giving you phone numbers, right? You might want to ignore spaces. You might want to ignore parentheses. You might want to You might want to ignore hyphens, right? A little bit more complicated, but that's the kind of stuff that you can use these for. Then there are some functions which will modify the string. More specifically, they will return a modified version of the string. So if you do this, s is equal to s.upper, it converts the entire string to uppercase. Now, if they're numbers, it leaves them alone. If it's punctuation, it leaves it alone, right? Similarly, s is equal to s.lower, converts to lowercase. What if you want to know if something is in a string? They've typed in a number, and I want to find out if there's a $sign in it so that I can treat it special if it is. If $sign in my string, then there is a $sign in the string. Here's another way to do it, which is you ask for the position of the $sign, and it searches the string. So if we had a string that looked like this, say s is equal to, $space Vader, and we wanted to find the position of the V, I want to make sure I don't get this wrong, because it's different in every language. Index of character Python. Good old Stack Overflow, where you'll find every answer in the universe. .find. All right. In Java, it's index of. So if your string is that, you could do I for index, something like that, is s.find and find a V. Returns the position of the V. And you don't even have to look for a single letter. You could look for the word Darth, right? Or you could look for a space, or you could look for TH, and it would return the place where that begins. Now in this case, where does V begin? I have to count. D is 0, 1, 2, 3, 4, 5. And so it's an index value 6. It is at subscript 6. What if we look for something that's not there? I is equal to s.find, and we're looking for the letter Z. Not found. So returns -1. So you can do stuff like if s.find whatever greater than or equal to 0, then manipulate it right. Or you could winnow it out to beforehand with a statement like that. Don't even go into the code. And time to play with that idea. Crank up idle. I'm on lecture P. No, we're on O. Don't know why I suddenly started typing in caps. All right. Let's make a string. Darth Vader. We want to find out if the word Vader is in the string. If Vader, vad, whatever, in S colon, print, yes, he's Darth Vader. I could have put the whole word in here, right? I could have made it if Vader. That would have made more sense. What if his name had VAD in it, but it didn't have Vader? But that gives the idea across. Else, colon, print. Nope, not DV. All right, and he was. What if we look for something that's not in there, right? Jedi. Jedi is definitely not in there. Okay, so it didn't find it. Now I should modify the messages, right? But anyways. What if we don't like spaces and we want to find out the position of the space in it? If string dot find parentheses quote in parentheses, and I think I'm doing this kind of wrong, I would rather store the position of the space, so I'm just going to call it pause for position, is equal to s dot find quote space quote. Look for index subscript of the space. If POS is less than 0, it didn't find it. Print, no space, parentheses in parentheses. Else colon, print, found a space. Now since we know the space is at position whatever I said, 0, 1, 2, 3, 4, 5, 6, what if we wanted to get the first name, right? That would be everything up to and including the space. Well, forgetting the idea that we have a variable called POS, what slice of this string would return the word Darth? What's the starting position of our slice? 0-based indexing, so that D begins at what position? Yep, so it starts at 0, and it ends, one past the ending of it is 1, 2, 3, 4. I think I'm doing this wrong. 0, 1, 2, 3, 4. We would stop at position 5. Right, so we could use a slice. Let's prove that to be the case. Let's print S subscript 0 colon 5. I'm going to see if I got that wrong. I mean right. I'm hoping it says Darth. Possible I'm wrong. Okay, Darth. Let's print out the message, the position. We found a space at, comma, POS. Just to let us know. Not POW, POS. So I just changed that line. All right, so we found it at 5. That's pretty cool because that's what we used here, right? So if we print out S at 0 colon POS, it's going to print out the same thing. And if this was a different string, right? Like, my name is Darth Vader. Well, the first 5 characters is wrong. Doesn't equal my name is, right? I mean, yeah, it printed out the first 5 characters. Position 0, 1, 2, 3, and 4. That's what slice 5 means, 0 through 4. But then it looked for the space. It found a space at position 2. I should have printed the name out as well so that we would know what we were looking at. And it did it. It got the first word. Everything up to the first space. Let's do that way up here. Let's just print out our string. Print S, quote, S equals, end quote, comma, S, so that we know what we're playing with. So I just added that. And I'm going to get rid of this one because it didn't make any sense after that. Instead of just printing it out, let's store it in a variable called first word equals S subscript 0 colon 5, not 5, up to the position. And then we could print the first word. Now, if there's no space, maybe we ought to print the whole string, right? The whole thing is the first word, right? Print. We've already printed out the string. We don't need to do it again. All right, let's make sure this is working cool. All right. It'd be nice if we said what that print was. So let's put a little description here on this last one. And we've made a lot of changes down to this code here. So you're going to want to check these last 4 lines very carefully. We're going to print the first word is, end quote, comma. Now I think our output's going to look a lot cleaner. Let's play with that dot upper and dot lower kind of stuff. Upper equals S dot upper. Lower equals S dot lower. Let's print those out. Print upper equals, end quote, comma, upper. Print, parentheses, quote, lower equals, end quote, lower. I wonder if it counts spaces as letters. Let's print out S dot is upper and see if it prints out true or false. We may wind up deleting this line. This is just out of curiosity. Not upper. I want to find out if it's all letters, and I'm curious if the space counts as a letter or if it will be rejected. Right? So if we print S dot is alpha, is it all alpha letters? Question mark. I want to see if it says true or false. See if that space breaks it or not. Well, what do you know? I misspelled alpha. There we go. It's probably about time for me to wander around and help with syntax errors. Let's give it I want to make a few more changes. All right. It's not all alpha because it found the space. Well, let's change our original data so there is no space. Maybe I'll change it again. Oh, there's a whole bunch of spaces though. All right. Take the spaces out. All right. Seems to be working. There's no space. Here's what it looks like uppercase. Here's what it looks like lowercase. Is it all letters? Yeah, sure is. So let's print out what we did here. I'm going to add a parameter to our print statement that says is alpha question mark end quote, just so that we know what it was printing there. And maybe I'm going to go back and add the spaces now. Doesn't matter, right? Yeah, sure, let's do it so that we can see that first word operation always working. Right. Time to make sure that we're all together. I don't recall if find works for lists. So I'm going to make a list that's got just our favorite numbers in it. 8, 6, 7, 5, 3, 0, 9. I could check to see, for example, if the 5 is in the list. If 5 space in space L colon print parentheses quote, we found the 5 in parentheses end quote. End quote in parentheses. Got those in the wrong order. Now let's get the position of like the 3. I'm going to see if it's dot find just like it is for strings. POS equals L dot find and I'm looking for a 3. And then just print out POS. It'll say -1 if it doesn't find it, otherwise it'll print out the index position. And list object has no attribute find. So I'm going to Google up the right function. Find element in list, Python.
Use list.index instead of, or L.index instead of L.find.
Okay. I was trying to shy away from that because I know what .index does. If it's a string and it doesn't find it, it generates an error. Like if we do this, don't have to do this, but if we just do s.index and tell me where Z is in that name Darth Vader, well, it blows up anyways because of that. Substring not found. Is the same behavior true if we use .index here? I'd like for it to return -1. It worked. Let's get rid of that because that's failing. What if we look for something that's not in it? Like a 1. Is it going to blow up or not? 1 is not in the list. Okay. If there is no version that returns -1, then you would want to check it first. You'd want to make sure that it's in the list before you search for it. So I'm going to modify these just a little bit. I'm going to take the last 2 statements off and do this. POS is equal to list dot, and by the way, thank you, index parentheses 5. And that's a magic number, and we ought to be storing it in a variable. And we can print out 5 was found at index. Let's get fancy. %d, end quote, %, POS, parentheses, in parentheses, or just in parentheses. All right, anybody remember, probably done the homework if you do, how I would take the S string and turn it into a list, breaking it up by the spaces. The spaces are the delimiter. Yeah, we'd use dot split. So, words equals S dot split. If we want to be specific on what breaks it up, split based on the space. I like doing that. Unfortunately, it gets more complicated if you want to say, I want to break it up by either commas or spaces. You have to do something a little bit more sophisticated, I believe. But this is good enough. 5 was found at index 3. True enough. We're not printing out the number. Perhaps we should, but yeah, why don't we add a print of the list right here, right? So above our for loop, our if, sorry, it's not a loop, we're going to just print the list out first, so that we can kind of enjoy the results of those 4 statements afterwards.
Want to print words as well?
Yeah, why not? Print parentheses words. And what if we wanted to recreate a sentence based on that list, but separating them by commas instead? You can use dot join. And the syntax for this looks kind of crazy. If you've seen it before, it won't look so crazy, but if you haven't, I'm going to call this one new underscore S because it's a new sentence based on the words, but we want them joined with commas between every word. New S equals quote, comma, quote, dot join, parentheses, words. I usually make my list just called capital L, but anyways, like that. That's going to take the words list, turn it into a string, every item separated by a comma. Like that. So now it's a list. I said it was going to be a string, sorry. It turned it into a list. I didn't print it out. That's what's going on. Alrighty. It is a string. Print, parentheses, quote, new underscore S equals, end quote, comma, new underscore S, end parentheses. Alrighty. New S equals my name is Darth Vader. If that's all we wanted to do, if we just wanted to replace spaces with commas, there's a faster way than converting it to a list and back into a string. There's the dot replace method. Like say we just hate V's. We hate capital V's. We're going to change, well, let's change the word my to your. That's what we're going to do. So we're going to say S equals S dot replace, quote, my, end quote, comma, quote, your, end quote, parentheses. And let's print out the new name, the new sentence. And so it did. It replaced my with your. What if we just replace one letter with another? I'm going to replace lowercase a's with something else. Print s dot replace, parentheses, quote, lowercase a, end quote, comma, and what am I going to replace those with? O's. End quote, in parentheses, in parentheses. So it's going to print out your name is Darth Vader, but with all the A's set to O's. Yep, your gnome is Darth Vader. Notice that we had to take the result of this one and we had to store it in a new string. In Python, as in Java, strings are known as immutable, meaning that they cannot be changed. Once a string is created, that memory is just kind of there. In some languages, you could say, okay, I want to change character I, character 3, to be a Z, and then it would. But in this language, you can't just change something with another. So what this does, what s.replace does, is it builds a brand new string with all the occurrences of I changed to your, or all the occurrences of A replaced with O. But if you want to store that, you got to put it here. Just like if you did this, x plus 3, that doesn't change the value of x, right? You got to store the result. A equals x plus 3, or x equals x plus 3, something like that. So this searches the string. It builds a new one with every occurrence of A replaced with O. But if you're going to do something with it later, you better store it in a variable. You're just going to print it out. I didn't save it in this one. I didn't save this replace. I could have, but I just printed it out instead with the return value of it. So that means that this did not change. If I printed out S one more time, we'd be back to your name is Vader. Because this returned a version of the modified text, but it didn't actually modify the original string. So if we try to do this, which is legal in some languages, the first letter in the string needs to be a Q. Now this is going to be a syntax error. We can't change the first letter of it like that. Boom. That works in some languages. However, we can change the first element of the list. What did I call my list? Capital L as usual. Yeah. L subscript 0 in subscript is equal to 99999. Now if we print the list out, it's no longer going to say 8675309. Print subscript L, or not subscript, print parentheses L. And it's there. Can't see it, but it's at the bottom. There we go. It did change the first element. So I'm going to add some comments. I'm going to put that back where it was, but I'm going to make it a comment. S subscript 0 equals a T. This is illegal because strings are immutable. Parentheses cannot be changed by indexing or slicing. It is totally fine and common to change lists by indexing. You can print out as subscript 0, and since our string says your name is Vader, the first letter in the string is a Y, and it would print it out, but you can't change it like that. Correct me if I'm wrong. Did I talk about binary and hexadecimal and octal on Tuesday?
I think you mentioned it, but I don't think you went too into depth.
Shucky darn. That was the other class. That class was irritating to teach because they only meet one day a week, and that was the hour that they decided to do the active shooter drill in this building. So we spent 20 minutes huddled against the wall with all the lights off and the shades drawn, holding a fire extinguisher to bash somebody in the head if they came in. But anyways, maybe it wasn't the best use of our time, but on the other hand, valuable.
Okay, the idea of binary is just that it's a whole bunch of zeros and ones. But if you want to display binary on the screen, you don't want to look at a whole page full of zeros and ones. Your eyes would cross trying to interpret them. So instead, you break them up into something that makes a little bit more sense to view. Ooh, let's turn them into ASCII. Well, that only works if it's actually typewritten text, right? Photographs and MP3s and executables and stuff like that are not typewritten text. So if you tried to print them out, for example, if I go and find an EXE or a PNG or something like that, let's see if I can find one really fast. It's already making me think I'm not going to find it really fast. Let's see downloads. Well, PowerPoint, for example. If I try to display one of those PowerPoint documents, ch07.pptx, well, that's garbage. That doesn't do me a darn bit of good. If I wanted to display it, I ought to display it in hex. Hex is the easiest thing to look at. It's where all the bits have been replaced into, or translated into numbers, where we have all the digits plus the extra letters A through F to represent the numbers 10 through 15. So, I got a quick way of viewing the contents of a file in hexadecimal, which is to go to hex, hexed.it, hex edit with a period, and then I can upload one of those files. And it'll display the hex version of it, right? This is a lot more useful to see than if it was just all zeros and ones. And yeah, we got some zeros here, but that's because there really is no data there at that point. And so usually the first part of a file is called the header, and it tells us something about it. I don't know about the PowerPoint format. And then if we start scrolling down, right, it's all, this is the text equivalent if it was converted to ASCII, but we're not finding anything. If we look long enough, we might find some, ooh, like this. PPT slides. Now that was stored as ASCII. So this is a hex editor. We could actually make some changes and save the file and probably break the format of it. What if I open a PowerPoint file? Alright, now we see the ASCII text here. It's converted all those zeros and ones into something that's readable, because in the ASCII translation actually works because a Python file is. Okay. So how are numbers translated into visible hexadecimal characters? They are broken up into little clusters of 4. Why 4? Hope you see what's going on. It's like an odometer. If I drive one more mile, the one flips back to a 0 and the next digit is increased. Now that I've hit 111, it's like hitting 999 on your odometer. It rolls back over. All right. So that's a 0 if we added them up. Yeah, and you know what I mean by adding them up, right? This is the 1's place, the 2's place, the 4's place, and the 8's place. Well, it ain't got any of those, so it's just a 0. But this one, for example, the 1's place is a 1, so we add a 1. But there's no 2, there's no 4. But we do have an 8, so that makes us a 9. And I'm not going to take the time to add them up like that for every one of them. I'm just going to go ahead and count and hope that I wrote them all down correctly. And then drag. What am I going to do here? Well, computer scientists in the 60s used octal, which is a counting system with only 8 digits, 0 through 7. So this last column was ignored, and every 3 bits that was in the computer's memory was replaced with a digit. And we could do that. We could break all this up into octal, right? So what is... I'm going to copy and paste just to make an octal chart by deleting the first digit of every one. So if I take this and I break it up into threes, like that, and so on. Don't want to belabor the point. What is a 0, 0, 0 in octal? It's a 0. And then what is a 1, 0, 1? It's a 5. What is an 0, 1, 0? Somebody look it up. Scroll down here. It's a 2. And what's next? 0, 0, 1? 1. And then 0, 1, 0 is a 2 again. And what's a 1, 0, 0?
4.
4. And then a 1, 0, 1 is a 5. All right. So that's how you could look at binary. That's one way of looking at it. Now, however, you're only seeing 3 bits. 3 bits is kind of a weird number. It's not a power of 2. You know, a byte is 8 bits, and you know, you can't divide a byte evenly into 3 bits, and so, not too cool. Instead, we're going to use hexadecimal. We have this chart down here, and we're going to display, oh, I didn't finish my chart. Hexadecimal means a counting system with 16 digits. And since we speak English, we arbitrarily chose A, B, C, D, E, and F as our last few numbers, as our last few digits. And then once, all right, I messed up. A, B, 1111 should be F. That should be an E. Oh, I just duplicated a number. All right, so there we go. That's our little hex to binary table. So we could break this up into clusters of 4 and display them. Like that. All right. 0001 is a 1. What's 0101? 5. And then a 00110, that's a 1, and now we have another 5, and then what's an 0010? And a 1010. And it looks like we have 2 A's in a row. And an 0010 is a 2. I seem to like that number a lot. And what's a 1011? And what if, just for fun, it ended up in 4 ones? That's an F. All right. So I would look at a screen, I would see that rather than seeing that many zeros and ones. It's easier for me to, and if you look at these numbers long enough, like you said, you start to understand what they mean, right? If a byte is 8 bits, then that's a byte, that's a byte, that's a byte, that's a byte, and that's a byte. We could translate that to ASCII table, or with ASCIItable.com. See if I can bang this over there. What are you telling me? Stop it. All right. Okay, so what does a 1-5 hex mean in ASCII? Well, if I Google it up, a 1-5 hex is a carriage return. Something's bugging me about what I just said. It would help if I had broken it out like this. Then my mind would not be freezing on this, right? All right, so that was a carriage return. Looks like we have another carriage return for some reason. And now we have a 2A. I was kind of hoping that this would actually have some real letters in it, but it doesn't look like it's gonna. I didn't manage to put any real letters in it. A 2A is a, need to make sure that we have time for me to give the homework assignment. So a 2A is a asterisk, and an A A2 is way off the end of the chart. It's a extended ASCII character that's way down here, and yeah, I'm not gonna even look that one up. Okay, and so what if I had these words on our screen? We had bad, B-A-D. Well, I could look them up, and a B, according to our ASCII chart, is a 66. Forgive me for already knowing what it is. And an A is a 65, and a D is a, but I wanted the hex values. I'm sorry, I am going to have to go look. So a B in hex, the ASCII value of B in hex is 42, and a D is a 44, and an A is a 41. And I could change this to binary using this chart down here. A 4 is an O100. A 2 is a O010. Another 4 is an O100. Another 4 is an O100. And another 4 is an O100. And lastly, that one here is an O001. So in my document, if I had BAD and then I opened it up with HexEdit, I would see these numbers. And underneath it all in the memory, we would see that. That really is probably all that we need to know about ASCII and hex. If the quiz asks more, there's not going to be anything about it on the exam, or at least very little, and if there is, I would review you appropriately. All right, homework. Ask the user to enter a sentence. Print yes if the sentence has the word the in it. Replace all e's with t's and print the result out. Find the first word of the sentence using .find. Well, I guess we could turn it into a list as well. And then slicing, just like we did in the notes for before. And store that in a variable name first. If that word is in all caps, print all caps. If it is not, convert it to all caps using the .upper method. Then print the word out. Lastly, just because I really want you to have the idea, even though we've already done this before, convert the sentence to a list and then print the first word of the list out, which is just going to be L subscript 0 if you called it L. All right, that's our homework. Makes sense? I think we covered this, everything that I'm asking you to do. Look wobbly, look good. I see some heads nodding. All right, make a Dropbox so we can upload this and vamoose.